Hello people on the internet, I hope you are doing great. In this video we are going to be talking about working with sensors using Arduino interface. So let's get started. Okay, so today I will be using this sensing element. It is called HCSR04. It is a proximity sensing element. So it works on the principle of a radar, which means that it basically emits ultrasonic waves through this emitter, and as soon as the waves bounce from any object, it reflects back to this receiver, and the sensor basically calculates the time between the emission and the reception of the sound waves. So there are several different varieties of projects that you can make using this Arduino sensor. Like you can have gesture controls, volume controls, like you can place the sensor at the bottom and you can just raise your hand up or down. So it will dynamically measure the length of the height. So it can raise or lower the volume accordingly. Similarly, you can make a system which will open the door as soon as someone walks towards it. So, but for today's project, we will be making sort of a volume control, but we will be writing the voltages to an LED. So, we will be measuring the length between the sensor and the hand, and the proportional amount of voltage will be written on the LED, and it will make it glow darker or brighter. So let's get started with that. Now for the circuit we'll be using an Arduino controller, the HCSR04 sensor, a small LED, and the cable to connect the Arduino with a laptop.
So now here I have already written the code and I shall be explaining the segments of it. So firstly I have defined the variables T, D and K. T is for the time that the sensor will measure, will be the distance, and K will be the proportionality factor. We are connecting the pins 8 and 9 with the anode and cathode of the LED. So I will just add a comment. Now the pins of the sensor have been connected to pins 11, 12 and 13. VCC is connected to pin 11. The other two are connected to pin number 12 and 13, that is the trig and echo, and the ground is connected to the ground. Now we are going to use the serial monitor just to make sure that the sensor is working fine. So I have added this serial begin and the frequency 9600. Now I'm initiating the main function. It will be the void function and it will go on in loop. So it is a void loop function. Now first of all I am writing analog voltage of 0 to pin number 8. So I am writing analog write pin 8 and 0 voltages. So it will be the pin 8 will be supplying 0 volt to the LED cathode throughout the code. Then I'll be supplying analog write 255. 255 implies it is 255 is the scaling of 5 volt to the VCC of the sensor. Okay. Now for the sensor to start activating and emitting the high frequency sound waves, it first needs to have 5 voltages of from the Arduino to the pin 12, that is to the triggering pin for 10 milliseconds. So I'll just write digital write to pin 12 and high means I'm writing 5 volts to 5 volts to trig pin. Trig stands for triggering pin of the sensor. Then I'll be waiting for 10 milliseconds. The bracket value states the time in milliseconds. So I'll just add a comment, time in milliseconds. 10 milliseconds. Then I'll write 0 voltage to the trig pin, so it will stop the emission of the high frequency waves. Then here's the formula of the time that the sensor will supply to the code. So the time variable is t, and it will be pulse in pin 13. So pin 13 will supply me the output of time. So pin 13, that is the echo pin will supply me, will give the time in milliseconds. So the time t will also be given in milliseconds. It is important to know that the time t will be supplied to the code in milliseconds as well. So now we know that distance is speed times the time, but the speed of sound in air. Speed of sound in air is about speed of sound in air is about 342 meters per second. But as you can imagine, the time taken will be considered 2 times the actual distance. So we'll actually divide the speed of sound by 2, and then we'll multiply it with the time given in milliseconds, and then we'll know the distance of it. So now I use this formula to find the distance of the object in front of the sensing element. Now I'll be running if else condition, that if the distance is between 30 centimeters, if the distance is between 5 centimeters and 30 centimeters, then the variable k will be assigned a value d minus 5, which is the subtraction of 5 from the distance that we will get from this formula. Now voltage of 2 times of k will be written to the pin 9, which is the anode of the LED, and it will delay for 50 milliseconds, and it will also print the value of k in the serial monitor, so that we'll know exactly what is the amount of voltage that has been written on the LED anode. So I'll just add a comment, writing voltage to the pin 9, that is LED anode. So if the distance is high, then the voltage written on the LED will be higher, and thus the LED will shine brighter. So now I'll just save the code, Control S, and I will then upload it on the Arduino.
Now we'll be joining the components of the circuit. Firstly, I will be adding the LED legs into the pins of the Arduino. the longer leg will be the anode and it will go into pin 9 according to the code, and the shorter line will be the cathode and it will go into the pin 8 of the Arduino. Now I'll be connecting the HC-SR04 sensor with the Arduino pins. In this, the requirement is that VCC should have continuous 5 voltage of 5 voltage supply in order to work. The ground will have continuous 0. The trig will have intermediate 10 millisecond 5 volt input, and echo will give me the output in terms of time. Now I will be connecting this. So the ground pin, that is the 4th pin, will go into the ground pin of this. The echo pin will go into pin 13. Similarly, trig pin will go into pin 11. Sorry, it will go into pin 12, and VCC the pin of VCC will go in pin 11. So I'll be just putting it like so. Some of the videos advocate the use of breadboard in order to have this connection, but I think it fits pretty well and there is no requirement of any breadboard connections. Finally, I'll connect the Arduino cable with it, and I'll connect the other end of the cable to my computer. Now I uploaded the code in my Arduino, and as you can see, the LED is not on as the distance is not in the range of 5 to 30 centimeters. Now I'll just place my hand behind the LED so as to have a contrast and be able to look the change in the brightness of LED. Now I will place my hand in front of the sensor and let us see what happens. So as soon as I place my hand in front of the sensor, the LED glows, and if I just bring it closer to the sensor, it should make the LED dim. So as you can see, the LED is going dimmer and dimmer as I take my hand closer to the sensor, and as soon as I take it away from the sensor, it goes on brightening up to 5 volts, up to 3 volts as in the code. So now I'll just try it again, and if I just remove my hand at some place, then it will be sticking at the same voltage that is been written in it the last time. So if I just do this and remove my hand, so it will be dim, but if I introduce my hand before the sensor and make it higher and then remove it, then it will be brighter. So that's our project. Guys, I hope you liked the video. I appreciate it if you made it till the end. I will pin the code used in this video in the comment section down below. You can also put your queries and doubts there, and I hope to see you in the next video. As always, thanks for watching.